Hello class, so this is CSE-5250, Section 2, Week 10. Week 10. We're almost through the semester already. I mean, look at the calendar. Halloween's right around the corner, and the next thing you know, it's going to be Thanksgiving and Black Friday and Christmas, and it's already in a new year. Yeah, so hopefully you've submitted your benchmarking assignment which is the midterm assignment. The midterm assignment called for benchmarking two different implementations of the sieve of Eratosthenes using OpenMP and MPI. The benchmarking may have been the most time-consuming assignment to date. So I'll just say right now that hopefully you've done that, and the rest of the class will be looking at more interesting applications of parallel programming, because it's one thing to know how to use parallel programming to look for prime numbers, but it's another thing to use it for other applications that might be practical or just interesting. So let's look at one application that's interesting, which is writing a parallel program that can brute force the seed for a random number generator. So this is going to be program assignment 3, and I've tentatively set the due date for November 4th, so the Friday of next week. Right, so let's look through the instructions. Program a random number generator that generate a sequence of 30 numbers from 1 to 20, and then write down the sequence of numbers. Then write a parallel program that tests all possible seeds to find the seed that generated that sequence of numbers. You may use OpenMP, MPI, or anything else that you may know. And I want you to submit onto Canvas a screenshot of the program running and successfully finding the seed and the source code. So that's basically your assignment. I alluded to this assignment last video, and here we're going to go through how the rest of this video is basically a walkthrough on what to do. I've included quite a bit of hints on what to do. So this video is going to be a little bit on the short side because it's going to be a repeat of last week, but also last Monday was when you had your assignment due anyway, so it's gonna be a little bit of a light week because of that. So how do we get started on this assignment? Well, now the usual way, let's start with the random number generator. The usual way of making a random number generator in C++ involves the rand function, but we need to first seed it using the srand function. We do that by passing in time 0 or time null. So it's srand time 0, and this seeds the random number generator using the computer's current time. So with the random number generator seeded, we can call the rand function, do a modulus operation to restrict the range of numbers between 0 and 19. But we want numbers from 1 to 20, so we have to add 1 to the result. So that's how we get our random number. So basically, we're telling a computer to simulate a whole bunch of dice rolls, and basically we're rolling d20s. So that's how we would do it using rand. There's another way using the random library for C++. So if we use that, we actually need two things. First, we need a default random engine, and we create an instance of the default random engine, we call it engine for our purposes, and we give it a seed. We can use the chrono library to pass in a seed, but we can, for our purposes, I've I found that using time 0 also works. So we'll pass it a seed that's the current time into the engine, and then we need a uniform int distribution, and we're gonna call it RNG because that's our random number generator. So a uniform int distribution, we need an instance of the uniform int distribution of a type int, and when we have to pass in 1 to 20, so that's our range of numbers to generate. So a uniform int distribution is basically a distribution where the probability of every outcome is the same probability. So basically, if you look at D20 like this, I hope you can see it, by the way. Every number on this 20-sided die has the same probability of coming up, which is 1 out of 20, or 5%. So that's what's meant by uniform int distribution. We want this to simulate our dice rolls. There are other distributions available in the random library, but we want the uniform int distribution. So how do we use that to make a random number? Well, we call RNG, and then we pass in the engine. And that's how it works. So, some of this is more how random number generators work, but I'll explain it anyway. So, typically random number generators, if you have to pass in a seed, then it's most likely not truly random. Instead, it's pseudo-random because we can effectively map seeds to output sequences of numbers. So if you want to find a seed for a specific sequence of numbers that were generated, we can try every possible seed until we find a seed whose output is the sequence of numbers we're looking for. So if we find a sequence that matches, we've found a seed. Or basically, this is basically brute force. And, well, brute force takes a while to run. This is why we want a parallel program to, in theory, reduce the time it takes to run. So, if we just use time 0 as our seed, how many possible seeds are we looking at? Excuse me. Well, time 0, or time null, returns the current time expressed as seconds elapsed since January 1st, 1970. So, if you think about 32 years as being a billion seconds, that's almost, if you look at, a billion seconds is about 32 years, and the time between January 1st and 1970 and now is almost 53 years already. So that translates to about 1.6 billion seconds since January 1st, 1970. So that's a lot of seeds for us to go through. However, we can cheat a little bit, and instead of just using time 0, we can use time 0 mod 100 million, so we have fewer seeds to deal with for the purposes of our program. So, what does this all mean? Well, if you want to go ahead with going through all 1.7 billion seeds, you can, but for the tutorial part of this video, I'm going to show what it looks like if we just wanted to restrict ourselves to a certain range of seeds. Alright, so let's begin with the programming section. Alright, so I've basically copied pasted the code from here for making our default random engine. Let's do the mod 100 million here. If we do mod 100 million, as I said, as I said, this will just restrict the range of seeds we have to go through. This is more for making the assignment easier to run, if anything. So, default random engine, when we pass in the time, we do a mod operation to restrict the time, to restrict the range of seeds we have. And then we have our uniform int distribution from 1 to 20. We call RNG, we pass it the engine, and that's a random number, and then we can just output it and see what we get. 14. Okay, let's try it again. 18. And every time you run it, we got 20 over there. Every time you run it, we get a different number each time. 1. But we want a sequence of 30 numbers, don't we? So, I'm just gonna remove that and comment that out, and I'm gonna make a for loop. And then I'm gonna see out our RNG engine, and then a space. And now I have a sequence of 30 numbers. And if I run it again, I get a different sequence, and a different sequence, and a different sequence. So let's bring out this one and put it in a notepad. I'll save that for now. And now, I want to know the seed that generated this sequence of numbers. How do we do that? Well, what we do know is the seed is some value from 0 to... What we do know is the seed is some number between 0 and up to, but not including, 100 million. So, that's our search range. If we just let it as times 0, I'm just gonna clarify what this means here. I added this mod 100 million because we don't want to sit here searching through all 1.7 billion numbers. So, what this means is we've locked the seed to some number between 0 and up to, but not including, 100 million. So, you have to write a for loop that looks like that. So, we have to write a for loop that goes through 0 to 100 million. So, let's copy that and write a for loop. Alright, so now let's just comment all this out. Oh yeah, by the way, I have all the libraries put in here already. So that's how I was able to get the default random engine. Again, it's under the random library, and seed time is for time 0. And in this example, I'm going to use OpenMP. So I have openmp.h here. Okay, so we have our for loop, but we also want the sequence of numbers. So let's just store that sequence of numbers in a vector. So I'll just copy and paste that from the notepad from before, and I have to put commas here. And there you go. Again, we want to find the seed that generated this sequence of numbers. So what we know is the numbers were between 1 and 20, and there were 30 of them. And the seed is some number between 0 and up to 100 million. So let's create another default random engine. So our candidate seed is going to be the I from the for loop here. So int seed equals I. So we also want to create the random number generator itself. So and we're gonna give it the seed, and then we want uniform int distribution. We know it's a number between 1 and 20. And we know there's 30 of them. Generate a sequence of 30 numbers and store them in a vector. So and then in another for loop, j 0, j is less than 30, j plus plus, and then we just push back random numbers dot pushback, and then we just push back RNG engine. Does the sequence of random numbers match the sequence we're looking for? We're looking for this sequence. Okay, so to do that, what we can do is, we can create a bool that's basically seed found equals true. And then we can go into another for loop. So let's just copy this again. And you say seed found equals generated numbers I double equals generated numbers j double equals random numbers j. Actually, no, that's only part of it. What we need to do is enclose that in parentheses and say seed found equals seed found and generated numbers j equals random numbers j. So this is a Boolean expression that says, does the jth number in the sequence of random numbers equal the jth number in the sequence of generated numbers? If so, whatever the result is, we end it with seed found, and it becomes a new value of seed found. A more terse way of doing this looks like this. So yeah, this is a terse way of writing the same exact code. It may be a more cursed way though. So what we could also do is if seed found is false, then we can just break out of the loop. Because if we find one number that's already, if we compare the 0th number between the generated numbers and the random numbers, if those two numbers don't match, we don't have to bother with reading through the rest of the numbers, so we can just break out of that, and hopefully that one small optimization will add up and hopefully make the program just a little bit faster, even without parallelization. But we want parallelization anyway, so we'll get to that soon enough. And if the seed was found, print it. I want print F for this. And that should be it. And to make sure the program ran to completion, I'm just gonna add this. No, not that. Right, so let's run this and see how long it takes for us. Okay, this is gonna take a while. So I'm just gonna stop the program prematurely, and because we want it to be parallel, how do you know that this is gonna be parallel anyway? Well, each loop iteration is just comparing it. It's just gonna try out one seed. Each loop iteration is gonna try out a seed, and then it's gonna see if that seed generated the same numbers as this sequence here. So, and no one loop iteration is gonna affect any other iteration. So, this is how we know that we can make it parallel in the first place. So we can just now we just parallelize the outer for loop because there are inner for loops here, and there isn't much to parallelize here, so we have to parallelize the outer for loops and not the inner ones, because if we parallelize the inner ones, we're just multi-threading the work inside the for loop. Rather, we're just parallelizing the work within the for loop, and because there's so much little work to be done, it might not be of any benefit at all to parallelize the inner for loop. So we want to parallelize the outer one instead. And we just run it, and now we wait. I'm just gonna turn off the camera for now. Yeah, I'll pause the camera for now, and then we'll come back once something happens. Right, so well, that took a while, and the program finally found the seed that generated the sequence of numbers that we had here. So what I'm gonna do is, well, we found the seed already, so I'm gonna copy that seed. I'll just write in a notepad as before, and 6690 4692. Yeah, I'll just copy paste that, and then and then I'll just stop the program. And alright, so we found the seed, and let's just make sure that this was the correct seed. So I'm gonna comment that out that code, and then I'm gonna comment out this code as well. And then I'm going to uncomment that, and then here I'll replace that with a seed. So we should get the same sequence of numbers as we started with. And look at that, we did 17, 10, 12, 1, 8, 18, 2, 10, 20, 2, 11, 3, and so on, 16, 6, 12, 11, and 5. Yeah, that's gonna be the gist of your assignment. So, as I said, try generating a sequence of random numbers, and then try finding the seed for that. And that's gonna be your, this is gonna be your next assignment, and that'll be due the Friday of next week. I'll have a submission field for that, and that's gonna be it for this week. As I said, it's a short video, and yeah. We'll also look at more practical applications of parallel programming later on. Mainly the next thing I want to look at is matrix multiplication. So, with that in mind, try this out, see if it works. If it does, submit that, and if you have any questions, let me know via email, and we'll take it from here. So, with that, see you next week.